The James Webb Space Telescope has found evidence of human activity far from Earth, bringing us closer to answering the age-old question of our solitude in the universe. The research for extraterrestrial life has been a constant throughout human civilizations, generating thousands of literary works and theories on the subject. Our fascination with our place in the universe and the possibility of not being alone seems to be ingrained in us, driving us to seek companionship, even if it's of extraterrestrial origin. We're getting closer and closer to finding answers to questions we really want. But are these answers really what we seek? Or is there something deeper at play? In 2021, the James Webb Space Telescope posed a hypothetical question about the future capabilities of our technology. Could our telescope detect artificial light on another planet, such as Proxima B? This exoplanet, the closest to Earth, lies in the habitable zone of our nearest neighboring star, Proxima Centauri, about 4.25 light-years away. Proxima B was believed to be locked in synchronous rotation, similar to the Moon with Earth, with one side always facing its star. The possibility was raised that a technological civilization on Proxima B could transfer the heat and electricity from the day side to the night side using probalictic cells that generated electricity from sunlight. Subsequently, a paper with Manas V. Lingam as one of the researchers showed that significant coverage of the day side with solar panels could be detected by future telescopes. Given that the James Webb Space Telescope represents a more advanced technological advance, now in 2024, there is a possibility that will allow us to expand our research for possible artificial lights on habitable exoplanets such as Proxima B. Thanks to its increased sensitivity and range of capability, the JWST may have discovered the light we've been looking for, which could propel humanity towards another great leap in its evolution. But before we dive into the implication of this discovery, it is crucial to understand how this feat was possible. The James Webb Space Telescope mission explores the mysteries of Proxima Centauri B. Throughout history, humankind has sought answers to understand the fundamental questions about the universe, our existence, and destiny. These common but extremely difficult questions have been driven humanity's curiosity for as long as we have been conscious. In the current era of exponential technological advances, the question arises as to whether we are any closer to finding answers. While a philosopher might argue that we are still at an early age in our understanding of the universe and ourselves, and astronomers would be excited to share the latest discovery about the cosmos, using the technological tools at his or her disposal. Although these advances often go unnoticed by the general public, they truly represent milestones in human evolution. Now, with the world literally at our fingertips, it is time to move forward and explore the universe in ways never before imagined. One of the ways of exploration is through technology, such as the James Webb Space Telescope. This instrument, heir to the legacy of human space exploration, is destined to answer fundamental questions about our place in the cosmos. It has already begun to shed light on the possibility of life beyond our solar system, as evidenced by the recent discovery of possible lights on a planet light years away. Proxima B, also known as Proxima Centauri B, is a superterrestrial exoplanet orbiting an M-type star. These planets, more massive than Earth but lighter than ice giants like Neptune or Uranus, are a unique class in the universe. Although much remains to be discovered and understood about Proxima B, this breakthrough represents a significant step forward in our quest to better understand our place in the cosmos. The first possible evidence of an exoplanet dates back to 1917, although at that time it barely captured the attention and recognition of the scientific community. However, it was in 1992 that the first detection of an exoplanet was confirmed, astounding scientists. Since then, many other exoplanets have been confirmed, with another notable example in 2003. By April 1, 2024, a total of 5,653 exoplanets have been confirmed, in 4,161 planetary systems, of which 196 have been more than one planet. These marvelous discoveries are mostly associated with M-type stars, also known as red dwarfs. Red dwarfs are the smallest stars on the main sequence that are considerably more common in the Milky Way than other stars. However, due to their low luminosity, observing them is not as easy as with other stars. Red dwarfs have different classifications and names according to their temperature and sizes, often designated as M dwarfs. These stars, with a temperature of about 3,900 Kelvin, have specific characteristics that distinguishes them. As Proxima B, its mass is estimated to be about 1.07 times that of Earth. Remarkably, it completes an orbit around its star in only 11.2 days, compared to our Earth year of 365.25 days. This gives us an estimate of the size of the star orbiting Proxima B. The star's luminosity is surprisingly low across the electromagnetic spectrum, at only 0.16% of the sun's luminosity. Moreover, in the visible spectrum, its luminosity appears even dimmer, emitting only about 0.056% of the sun's luminosity. More than 85% of the energy it emits is in the form of infrared radiation, and it orbits at a distance of about 0.4856 astronomical units from its star. The discovery of Proxima B was announced in 2016, which raises the question of why this particular exoplanet has generated so much interest. One of the reasons is that Proxima B is the closest known star to our Sun, albeit at a distance of 4.2 light-years, which, while larger to us, is relatively short on a cosmic scale. It is part of the triple star system known as Alpha Centauri, and despite its low luminosity, remains an object of great interest to astronomers. The Proxima Centauri system stands out as one of the constellations visible in the night sky, ranking behind only two others, known as Sirius and Procyon. However, the most intriguing thing about Proxima Centauri B is its potentially habitable position within the habitable zone of its star. Possibilities they suggest are limitless, which has led astronomers to embark on an expedition to explore the depths of this stellar potential. This is where the James Webb Space Telescope comes into play. The four main goals of the JWST include searching for light from the first stars and galaxies that formed after the Big Bang, studying the formation and evolution of galaxies, understanding the formation of stars and planets, and investigating planetary systems and the origins of life. As JWS continues its exploration of exoplanets such as Proxima B, we move ever closer to achieving these goals. The search for extraterrestrial life is a particular area of interest in space exploration. The Search for Extraterrestrial Intelligence (SETI) project stems from the curious nature of humanity, exploring all that moves and all that does not move. SETI imagines a kind of cosmic treasure hunt, where instead of gold, we are in search of electromagnetic signals that could be whispers of civilizations beyond our wildest imaginations. If you liked the video, remember to like, subscribe, and turn on the notification bell. Thank you so much for watching.